Hi, I'm Changyeo Lee, and today we learn about the lithography, um, and this is the lithography of principle. So we make patterns selectively, and it's the uh, purpose of the lithography. And mask is act like mask itself. So we can connect with mask with photolithography, and lithography means uh, lithography is important to mass production and selective patterning. Mm, and uh, we learn about the load to low. So it is procedure, but it is expensive. So photo fabrication is making the mask and uh, 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 to the light and exposure. And after exposure, developed it and use the developer and uh, this procedure. So it's the stencil is the uh, example of the photography result photolithography. And so first the PR is the photoresist. So if the we receive the lights, that structure of the chemical structure is changed. So broke the connection and uh, part of the receiving lights is selectively remain, and other parts is if the other part is weak, it is selectively uh, receiving light part is developed, and if a few times later it is flow away. So this can make selective pattern. So we need the mask to receive the selectively receiving mask. So for the fabrication of semiconductor, various kinds of mask is necessarily. So mask um, so each pattern of the mask is various. So coated from chrome, uh, uh, coated part of chrome is not approaching the lights, but if the hole is exist, uh, that part light can emit it. So this is the operation of the photomask. Uh, Order of the fabrication is also important. So this is the example of the wrong fabrication order of the semiconductor. Uh, this is the real simple process of the fabrication of semiconductor. And we learned about the photomask like electrical, and and we learn about the misalignments. Uh, it, so to improve to resolve the problem of misalignment, we the knob of the misalignment we use alignment key, uh, uh, aka marker. So and we also learn about the pellicle, the protector of the mask. So and and we learn about the photolitho step. So first clean the wafer and coat with photoresist, and after the coat with photoresist, we can continue to soft bake and align masks, exposure pattern, develop photoresist, and also one more bake hard equals hard bake, and etch window in barrier layer and remove photoresist. It is if red check part is the common photoresist order, and we learn about the self-aligned mask. Mm, mm, Self-aligned mask means uh, uh, mm, reduce the step of the fabrication step and reduce about the cost of the fabrication step. And vertically scaling down is so limited, so high K materials is used. So uh, surface strain surface strain at the surface strain at the surface strain lifted something and gave the stress. Uh, the modulation of the channel EK diagram and reduce the effective mass and improve the channel mobility of the device and improve the driving current. It's the train engineering. And uh, so punch through is the short channel effect. So we use the multi-gate, and after this class we learn about the clean room, about equal fab. And clean room is we can fabricate about the semiconductor, and we learn about the FOUP and FOSB and LOT, and also yellow room, and and overhead hoist transport like OHT. And so small pattern we use the photolithography, and the detail about the photoresist equals PR. We use spin coating. So PR separate negative PR and positive PR. If light is emitted, negative PR means if the receiving the light, that part is so close linking, and remain the use developer, and we remain this part only. But positive PR means the break about the combination. So after we use developer, that part is go away. So use the photo mask. So selectively light is selectively emitted and receiving and outsiding. So and we can exposure it. So we don't want to remain the residue. So cleanly develop is needed. And this is the procedure about the negative PR and positive PR. And we learn about the optical system, vapor exposure system, and contact printing, and proximity printing, and projection printing. And we also learn about the stepper and advanced stepper like scanner, and how we learn about how to make pattern smallly, and numerical aperture and depth of focus. And we learn about the important formula equation like Lely's equation. And the important key of the Lely's equation is critical dimension and numerical aperture, and depth of focus. These three parts is important. And to measure the CD, we use the CD SAM and light source, DUV, EUV, and we also know about the details about the photoresist and cutting measurement. And finally, we'll deeply learn about the soft bake and deep cutting and spray cutting and defects and cleaning features.